Hello everyone, and welcome to our Marelli webinar series. Today we're going to discuss about our generator datasheets and derating factors. My name is Elvis Thanaj, and I will be your host for today's webinar. I want to point out that we have a Q&A section in this webinar, and two applications engineers will be answering your questions. If time's up and we miss some of your questions, we will follow up with an email. So today we're discussing about our datasheets. We're going to see an overview, our model nomenclature, our standard datasheets, our custom datasheets, and then see the graphs and curves. Later we're going to discuss about our derating factors based on climate conditions and load types. And ultimately, we're going to see our Marelli Motori website resources. You can see here our basic datasheet configurations. On the left screen, you can see our multi-voltage or standard datasheet, which is typically referring to low-end generators, low power end generators, and low voltage generators. Typically those off the shelf, if you will, generators. On the right, on your right hand, you can see a custom datasheet for customized voltage, medium and high voltage, and various power ratings up to 15,000 kVA. Before we go to the datasheets, I would like to point out and describe our model nomenclature. So for this generator, the MJHRM stands for the model series. In this case, this is a marine generator with a heat exchanger, air to water heat exchanger on top. The 800 indicates the height, the shaft height, which is the distance between the base of the generator until the middle of the shaft. In this case, it is 800 millimeters. The MA indicates the length of the frame or the barrel. You will typically going to see S's, M's, and L's, which stand for small, medium, and large. The number 10 indicates the polarity of the generator. This is a 10-pole generator. Looking at our standard datasheet, the multi-voltage datasheet, your data is going to be based on an ambient temperature of 40 degrees C, the temperature rise H, insulation class H, and the power factor of 0.8. They're divided in frequency of 50 Hz and 60 Hz. There are two basic connections, the star series connection or the high Y, you can see the configuration down here, and the star parallel, which is the low Y, you can see the connection right here. Each voltage has a maximum power for this generator. So for this example, we're taking an MXPE 250 frame LB4. So this generator at star series for a 480 volt, it can deliver 300 kW. At 208 volt star parallel connection, it can deliver 260 kW. You can see the power is less than the 480 at a 208 volt because when the voltage goes down, the amperage goes up, and that has an effect on the power output of the generator. Below each power and voltage, you will see the relative efficiencies in 0.8 power factor and power factor 1. Further in the datasheet, you can see some more information on the standby rating, standby efficiencies, and the reactances for this generator MXP 250 LP4. At the end of the page, you'll see some more general information on the weight, the inertia, the overspeed, and so on and so forth. The next pages of this datasheet are the curves and the graphs based on the first page we just saw. Let's see an example. This efficiency curve, it refers to this 480 volt, 60 Hertz request. So at 480 volt, 60 Hz, this generator delivers 300 kW. When the generator is loaded at 300 kW, or the 4/4 of the load, which is the full load, it has an efficiency of 93.9%. At 3/4 of the load, it has 94.3, and 2/4 of the load, or half of the load, which is 150 kW, this generator's efficiency is 94.1. You can see this illustrated in the graph that you see below here for power factor 1 and power factor 0.8. In the next pages, you will see a graph called the voltage dip curve. This is an interesting graph, especially when you want to select a generator based on the load character that you have. When you apply a load to a generator, this is affecting the voltage of the generator. So for this 480 volt generator, let's take an example. You're going to see multiple lines in this curve. Each line is referring to a specific configuration of this generator MXPE 250LB4. So the deep blue line is the shunt configuration, which is the basic factory configuration. The auxiliary, the gray line, is the auxiliary plus our analog AVR configuration. The light blue is the analog, is the auxiliary with the digital AVR, our MEC20. The purple configuration is with a PMG and an analog AVR. And the blue is the PMG with a MEC20, our digital AVR. The PMG is a permanent magnet generator mounted on the rear end of the generator. We will cover the PMG in the next webinar. Let's see an example. For instance, for the sake of this presentation, we are going to focus on our auxiliary configuration, which is the auxiliary winding with the analog AVR. This is our standard configuration here in Marelli, USA. And then we're going to compare it with the top of the line PMG with the MEC20 digital AVR. So for the auxiliary winding with an analog AVR, when this generator is loaded at 400 kVA, the voltage drop is 12%. In a different configuration with a PMG and a MEC20, our DVR, when loaded at 400 kVA, the voltage drop is now 7.5%. You can see there is an improvement in voltage drop. This is because the PMG, in conjunction with the digital AVR, are more efficient in managing the voltage variations. In another example, if you have a specification calling for a specific and certain percentage of voltage dip, in this case we have 15% voltage dip, this is helpful to understand what is the load step, the maximum allowable load step. So by looking at the 15% and following the line, you can see that for a configuration with a PMG and MEC20, the maximum allowable load step is 745 kVA. Let's look at our custom datasheet. Our custom datasheet consists of 5 pages. And again, in this first page, you will see most of the information you are looking for. You have the generator type and name, which is the MJHRM 800 MA10. You will see the temperature rise, the installation class, the mounting, the ambient temperature, which is 50 degrees C in this case, very typical for marine generator as this one is. The protection degree, which is IP44, and that's achieved with a cooling system of IC81W, which is the air-to-water heat exchanger mounting on top. Further on, you will see the frequency, the voltage, 13,800 volt, and the amperage at full rated load, and the rated load is 3,600 kVA. Further in these data sheets, you will still see the efficiencies based on power factor 1 and 0.8 and the reactances of this machine. And in the next pages of this data sheet, you will see again the efficiency curves and the voltage dip curves. Talking about the derating factors. In our power generation selection guide, where you can find it in our website, in the first pages, you will see a page called the derating factors. These are the factors that affect the power output of the generator. And these are altitude, ambient temperature, power factor, configuration, or connection. Let's take a simple example, which is the most common one, the ambient temperature. For ambient temperature up to 40 degrees C, there's no deration, which means the power output that is the nominal one in this selection guide, it is not going to be affected. For any temperature above 40 degrees C, we have a deration of that power. So for a 100 kW generator at 50 degrees C, the derating factor is 0.93, which means you have to multiply the nominal power 100 kW times 0.93 and you'll come up with 93 kW. This is the maximum allowed power output for this generator at 50 degrees ambient temperature. The same logic applies for the altitude and the power factor. And when we're looking at the IP configuration, which is the international protection, in this case, the ingress protection, for a configuration with IP23 and inlet filters, this will have a derating factor of 0.95. If an IP43 is required with inlet and outlet filters, the derating factor is even lower, is 0.92. And for IP44 is 0.9. We have some derating factors also based on the connection, star series, parallel, and series delta. Those don't have K factors, but each power node is indicated in the pages in the selection guide. You can find our standard data sheets in our website, www.marellimotori.com. Under the download section, you can select the product, generator in this case, the model MXP250LB4. When you select the model, you will be prompted to a download page to download the datasheet. If you do not know the model, in this section here on the left, you can enter your kW, your voltage, and your frequency, and the system will select a model for you. In order to download any documentation, you will have to log in. If you do not have an account, please subscribe. It's very easy, it takes less than 1 minute. If you have any questions, or you are requiring a custom datasheet, please feel free to call your sales area manager. If you do not know who your sales area manager is, go under the contact section of our website, type in your country, the region, and the product you're interested in, and you'll find the reference and the contact information of your sales area manager. Thank you very much for attending this webinar. In our next webinar, we will discuss about our Marelli AVRs, analog and digital. Thank you.